Hello students, welcome to chemistry online classes. In last class, I have given you one homework to express these numbers into scientific notation. We have seen why numbers are to be expressed in a scientific notation, because we are dealing with very large numbers as well as very small numbers, and in order to have mathematical operation in a simple way, they have to get converted into the scientific notation. So this is first number I have done 136.225. This decimal point I have to shift here after 1. If I shift decimal point after 3, it is 13 and it is greater than 10. So we should make it smaller than 10. So I have shifted this decimal point here. In that process, we have shifted this decimal point towards the left. That's why the power of 10 should be positive. And what should be that number? That number should be the number of places we have shifted. So this is, if I put decimal point here, it is 1 place. If I shift the decimal point here, it is 2 place. So that's why it is 10 raised to plus 2. Now in the second example, I have to shift this decimal point after 2. 1, 2, 3, 4. Right, that's why minus. 4 places, that's why 4. Here the decimal point is to be shifted after 1. 1, 2, 3, 4, 5. Towards left, plus. Nothing is written, is plus. And 5 places, that's why it is 5. Here we can put decimal point here and put 0 here. So the decimal point is basically after 7. We have to shift that decimal point after the 4. So 1, 2, 3. That's why number 3. And we are moving towards the left. That's why it is plus 3. In this example, we have to move this decimal point to the right. So negative 1, 2, 3. So it is negative 6.8. Here towards the left, positive 2 places, plus 2. Here there is no need to shift this decimal point to any place, because if we shift here, it is 70, which is greater than 10. So already it is in scientific notation. We have not shifted it to anywhere, so we can write theoretically into 10 raised to 0, because we have not shifted it anywhere. 10 raised to 0 is 1, so we will get the same number. So it is better to be left as it is. 3, 2, 5, 6, it is towards the left, plus 3 places, 3.256 into 10 raised to plus 3. I hope that you understood this example. In annual examination, some questions are seen on this part for 1 mark. It is very simple part. Also, I have given you some simple questions. I have already solved on the board so that you can save time. You might have completed these questions also in the homework. So first one is 5.6 into 10 raised to 5 multiplied by 6.9 into 10 raised to plus 8. So I have this multiplied 5.6 into 6.9, which happens to be 38.64, and this 10 raised to 5, which is to be multiplied with 5.6, and 10 raised to 8, 6.9. I have added them, because multiplication means the power should be added, powers of 10 should be added. So it becomes 13. This decimal point I should shift to the after 3 towards the left. So it should be multiplied by plus and 1 place, so 1. So I have written this 38.64 as 3.864 into 10 raised to 13. It comes from the question itself. Multiplied by 10 raised to plus 1, this 10 raised to plus 1 I have written, because I have shifted this decimal point after 3. Then this is 3.864. This is plus 13 plus 1. So I have written it as plus 14. Simple, not at all difficult. 9.8 into 10 raised to minus 2 multiplied by 2.5 into 10 raised to minus 6. I have made this number in one bracket, 9.8 into 2.5, 10 raised to minus 2 plus minus 6. the powers are to be added in the multiplication. 9.8 into 2.5 happens to be 24.5. This minus 2 plus minus 6 is minus 8. Then I have to shift this decimal point after 2. Towards left I am shifting it, I have multiplied by 10 raised to plus 1 because only one place I have shifted this decimal point, and it get ultimately converted into 2.45 minus 8 plus 1, which is nothing but minus 7. In third example, 2.5 divided by 5.5, 10 raised to minus 3, because it is multiplied with 2.7, divided by 5.5 into 10 raised to plus 4. That's plus 4 becomes 10 raised to minus 4. I have simplified this 2.7 divided by 5.5 as 0.4909. With simple calculator, you have to do these calculations. Minus 3 minus 4 minus 7. I have to shift this decimal point after 4. I am shifting it towards the right. Negative 1 place, negative 1. 4.909 into 10 raised to minus 7 into 10 raised to minus 1. It happens to be 4.909 into 10 raised to minus 18. Minus 8. This 6.65 into 10 raised to plus 4 plus 0.895 into 10 raised to plus 4. I have taken 10 raised to plus 4 as a common. I have added these two things. It becomes 7.545 into 10 raised to plus 4 as it is. No need to shift this decimal point anywhere because already it is in the scientific notation. 2.5 into 10 raised to minus 2. From that we have to subtract 4.8 into 10 raised to minus 3. Now powers of tens are different here. We should make them equal. I should you make this minus 3 or you make this minus 2. Anything will work out here. So this minus 2 I have converted to minus 3. Means I have multiplied by 10 raised to minus 1. How? I have shifted this decimal point towards the right, one place. 2.5 becomes 25. 10 raised to minus 2 multiplied by 10 raised to minus 1 becomes 10 raised to minus 3. And this 4.8 into 10 raised to minus 3. Now 10 raised to minus 3 is common. I have taken it out of this bracket. 25 minus 4.8 is 20.2. Then I have shifted this decimal point here. 2.02 multiplied by, I have shifted this decimal point towards the left. So plus 1 place, plus 1. 2.02 multiplied by 10 raised to minus 3 plus 1 is minus 2. I hope that you understood these simple mathematical operations. Of course, there is very less possibility that question can be asked on this because you learn it in school level. But as more and more mathematical operations we need to do in PUC first year, I have particularly solved this example. It is there in our syllabus, so that's why I have stressed on it. Now today we will go ahead and one more type of important questions we have to solve today. This type of questions are seen in the previous examinations. What we have to do? We have to convert one unit into another unit, and most probably they will ask to convert that unit into the SI unit. So for example, if we have kilometer is not the SI unit of length, it is meter. So kilometer is to be converted into meter. For that, we need to do some mathematical operations on a number and the unit, and we'll get ultimately that conversion done. So I will solve some questions on the board. Not at all difficult, but some students might feel it difficult. So patiently you listen. You solve 2-3 times and automatically you will understand what exactly we are doing this. Maybe new method for you. So we'll do enough practice of it so that everything will be clear. So I'll write question and we'll solve it one by one. Very important part because in MCQs also it can be asked, so that's why you should take these examples seriously. You should solve them. verify your answers. I have already solved this all homework questions, and if any difficulty is there, you have to clarify it personally. So the question is express each of the following. Express each of the following in the SI unit. See the question. Express each of the following in SI unit. The first example is 1.35 millimeter. Now this millimeter is not the SI unit, meter is the SI unit, and we need to convert this 1.35 millimeter to the meter. See how we do. 1.35 millimeter, I have to multiply it with, see what I will write, 1000 millimeter is equal to 1 meter. Relation between the given unit to the meter to which we have to convert this is 1000 millimeter is equal to 1 meter, because 1 meter is nothing but 10 raised to minus 3. This is 1 by 1000, which is nothing but 10 raised to minus 3 millimeter. So that I have written here. Why we have multiplied it this way? Because we can cancel this 1 meter and 1000 millimeter, they are of same magnitude. So effectively we are multiplying this by 1, which doesn't change its value. But we are converting this millimeter to meter. How? This is millimeter in numerator and this is in denominator. So we can cancel it. So I will cancel this. This 1000 is nothing but 10 raised to plus 3, and when it is in numerator it will be 10 raised to minus 3, right? So what I will write here? I will write 1.35 into 10 raised to minus 3 meter. Simple, isn't it? Only thing is that we should write appropriately. This millimeter in numerator, this should be in denominator, so that we can cancel it. And that should be related to meter, because it is the SI unit. They ask us to convert this in the SI unit of length. That's why 1.35 millimeter is nothing but 1.35 into 10 raised to minus 3 meter. Very simple. Some examples are difficult. We will see that. So this is now question number 2 now. One day we have to convert this into seconds. We want to know how many seconds are there in one day. So I will write here 1 day, and I will write 1 day here in denominator, so that I can cancel this day and day. And I will write here 24 hours, because 1 day is equal to 24 hours. But hours is not in SI unit, time. So I will write here 1 hour. So that's this 1 hour and this 1 hour is cancelled out. But 1 hour equals to what? 60 minutes. But minute is also not the SI unit. So I will multiply this with 1 minute, and that equals to 60 seconds. Right. So ultimately days are to be converted into hours. Hours are to be converted into minute. Minute has to be converted into seconds. Now this day in numerator, denominator cancel. These hours cancel. Minute cancel. So what we have now? We have now this 24 into 60 multiplied by 60, that is in seconds. And if we do all this calculation, I have already done this, you can also do it with simple calculator. You can pause this video and you can do this so that you can verify it. 86400 seconds. So I can write this into the scientific notation also. I'll write 8.64 and 1, 2, 3, 4. So I will write 10 raised to 4 and I will write it as second like this. So this is the second example where the 1 day converted into seconds. 1 day equals to 86,400 seconds. And this is the way, simple way in which directly the day unit converted to the second unit. I hope that you are understanding. It's not difficult, but very we should be very articulate in this calculation, in arranging these units. And of course, this you will get by just practicing, solving again and again and understanding. We have enough practice of it so that you can understand it. See the third question. Now 6.45 millimeter. We have to convert this into cubic meter volume unit. So you can write this as 6.45 milliliter. And I will convert this to first liter. I will write 1000 milliliter is equal to 1 liter. Liter is also not SI unit. Now I will write 1000 liter is equal to 1 cubic meter, because this is same. So 1 multiplied by 1, we are not changing any value of it. Multiplied by 1, we are not changing any value of it. But our units are converted into desired units. Milliliter, milliliter, liter, liter. We are cancelling out. And what we are getting now? It's 6.45. This is 10 raised to plus 3. This is 10 raised to plus 3. So multiplied by 10 raised to minus 3, multiplied by 10 raised to minus 3. And it happens to be 6.45 into 10 raised to minus 6. And I will write here as cubic meter. Right. See the question number 4 now. 48 microgram. They are asked to convert this into kilogram. We'll do that. 4.48 microgram. And I will write here conversion as 1 gram is equal to 10 raised to 6 microgram. Isn't it? Because this micro is nothing but the 10 raised to 6. So 10 raised to 6 microgram is equal to 1 gram, because 1 gram is equal to 10 raised to minus 6 microgram. So 10 raised to minus 6 is nothing but 1 by 10 raised to 6. Then kilogram we need to convert into it. You can write this as 1000 gram is equal to 1 kilogram. This microgram, microgram, gram, gram, we can cancel out. And then what we have? 48 into this 10 raised to plus 6 becomes minus 6. And this plus 3 becomes minus 3. So it is 48 into 10 raised to minus 9. We can write this as 4.8 into 10 raised to, we have shifted this to right, to left, plus 1 into minus 9. 10 raised to minus 9 into 10 raised to plus 1 is 10 raised to minus 8. And we can write now kilogram as the unit. So it is 4.8 into 10 raised to minus 8 kilogram. See the next one, fifth one. 0.0426 inch unit of length. We have to convert this into meter. We have to write like this 0.0426. I'll just write here because this will be sufficient. So it is 0.0426 inch equals to 1 inch is equal to 2.54 centimeter, and we can say 100 centimeter is equal to 1 meter. So this inch cancel, centimeter cancel. So what do we have? 0.0426 into 10 into 2.45 into 10 raised to this 100 is plus 2. It becomes minus 2. So 4.26. We have shifted this towards the right, minus 2. 2.54 into 10 raised to minus 2. And if I multiply this together, it will be 10.82 minus 4. And I write here as 1.082 shifted towards left multiplied by plus 1. It is minus 3, and I will write it as limit. So you understand this example. First you solve this. You can just pause this video and see whether you are getting or not. Yes, see these examples. Right, so I will rub these examples and we will go for another examples. See here, the next one is the sixth one. Miles per hour is to be converted into meter per second, isn't it? Speed, meter per second. So, see the conversion here. 100 miles per hour. 1 mile equals to 1.6 into 10 raised to plus 3 means 1600 meter. So we got meter here, but we per second. 1 unit we got meter, which is assigned, but this hours has to be converted into second. That we can do easily. That is nothing but 1 hour. Now this hour is in denominator. It should be multiplied now in numerator, so that this hour and this hour we can cancel. That's why I am saying every question there is no one clear-cut formula for it. Every time, but to rearrange it in a unique way. So it is 60 minutes, but still we don't want in minutes. We want in seconds. So we can write 1 minute equals to 60 seconds. Yes. Now everything is clear. This minute is we can cancel. This mile we can cancel. This hour we can cancel. And what we are left with now? We are left with now this 100, which is 10 raised to plus 2, 1.6 into 10 raised to minus 3 divided by this 60 and 60. So I can write 3600 directly. So what is the ultimate answer here? 1.6 into 10 raised to plus, it is plus 20. So is equal to into 10 raised to 5. This is 00, and that happens to be 0.000444, isn't it? You also do calculations simultaneously. So it is 4.44. 1, 2, 3, 4. So it is into multiplied by. See this I have done only for this part. Into 10 raised to plus 5 is still there. So plus 5 is nothing but 1, 2, 3, 4 and this is 5. So it is 44.4, isn't it? 44.4, and I will write now meter per second, because already what remains here is nothing but meter per second. So this 0.000444 is for 1.6 by 13600, and this 10 raised to 5 I have multiplied with it and we get that number. Of course you can convert this decimal point here, 4.44 into 10 raised to plus 1, also you can write it. So this is meter per second is the unit in which it is converted. The next one is very simple. It is 46 degrees Celsius. Kelvin is the SI unit, just add 273 to it. 46 plus 273, 6 plus 3, 9. 7 plus 4, 11, 1. It is 3193. Is the answer. Right. So this is the 7th question. Now 8th one. If you are understanding this, you can pause the video and do yourself and verify the answer. Right? Because some students might have picked up this concept. Some are not. Let it be. We have enough time, isn't it? You can come and personally you can get it clear. There is nothing is difficult in this calculation. So next is 8th one. It's 2 liter. In cubic meter we have to convert. Very simple. 2 liter into 1000 liter is equal to 1 cubic meter. Enough. 2 multiplied by 10 raised to minus 3 cubic meter. Liter cancel. This is 10 raised to plus 3. And this is minus. Right. Ninth one is 93 million miles, which happens to be distance between Earth and Sun. 93 million miles. We have to convert that into meters. How to do that? First we will know convert this million. It is nothing but 10 raised to plus 6. So 93 into 10 raised to plus 6. For this million I have written this 10 raised to plus 6. Then I have written this mile, and I will write 1 mile is equal to 1.6 into 10 raised to plus 3, 1600 meter. Same. Here I have written. This mile get cancelled. 93 into 1.6 into 10 raised to plus 9. 93 into 1.6. I am getting 148.8 into 10 raised to plus 9. So I will write this as 1.488 10 raised to 11, because 2 places decimal point I have shifted towards the left. Now it is in meter. So this is the million miles converted into meter. The next one is 1.54 angstrom unit. Angstrom unit, and that is nothing but average distance. Average distance between carbon atoms in diagram, and that way to convert into meters. Very simple. 1.54 angstrom unit, and I write 1 angstrom unit is equal to 10 raised to minus 10 meter. 1.54 into 10 raised to minus 10 meter. Right, very simple these examples are. See the next one. We have to practice it, that's why I am taking more examples. Patiently you solve, don't skip any example. 11th is 1 and small f g. Small f. They are not given this in question, but I will write it for simplification. 1 femtogram. 10 raised to minus 15 gram. Right. It is the mass of, very small, mass of human DNA molecule. Very small mass, it is 1 femtogram is equal to, we can write this as 1 gram is equal to 10 raised to minus 15 femtogram, and we can write 1000 gram is equal to 1 kilogram. We want to convert that into kilogram. This femtogram we can cancel, this gram we can cancel, this is plus 3. So what we have now? 1 into 10 raised to plus 15. This minus 15 becomes plus 15. And this plus 3 becomes minus 3. And that's why we can say 1.10 raised to plus 12 kilogram. Yes, this is the, no, this is 1 femtogram is see whether I have 1 femtogram is equal to 10 raised to minus 15 gram. So no, it is correct only, right? So this is 1 gram. So if we put it 1 gram, this will be 10 raised to minus 15. And this is 1000 gram. I have done that. This is plus 3, so it is minus 3. And this is 15. And this equals to right, 10 raised to minus plus, how it become plus 1 Fg, and no, here that's why I said it's very precisely we should do it. 1 Fg is equal to 10 raised to minus 15 gram, and 1000 gram is equal to 1 kilogram. That should be the case, isn't it? So we should, you understood this, 1 femtogram is equal to 10 raised to minus 15 gram, and this gram I have to arrange here, so 1000 gram is equal to 1 kilogram. So this gram, this femtogram, what we have cancelled, so equals to 1 into 10 raised to minus 15 multiplied by 10 raised to minus 4 kilogram. That's why it is minus 80, right? Kilogram. Right. This will be the correct answer. 12th one is 500 megagram. Mega is 10 raised to plus 6. Mass of loaded jumbo jet. Mass of loaded jumbo jet. So this is 500 megagram, and we can write 1 megagram is equal to 10 raised to 6 gram, and 1000 gram is equal to 1 kilogram. Gram, megagram cancel. 500 into 10 raised to plus 6, 10 raised to minus 3. So it is 5 into, this is plus 2 and plus 6 plus 8 minus 3, and it is plus 5 kilogram, right? Because 2 plus 3, 2 plus 6, 8 minus 3 is 5. So basically it is 5 lakh kilogram, right? So 3 still we do so that we can now practice. Then I will give you some homework also. Practice is needed. That's why again I am stressing it. Without practice, you cannot solve this type of questions. The next one is 13th one. Is 120 nanometer, and it is the average diameter of coronavirus. I have taken this from Wikipedia. 120 nanometer. Of course, there is range in virus, but this is average. 120 nanometer, and we will write 1 nanometer. 10 raised to minus 9 meter, isn't it? So this I will cancel. Minus 9 meter. 1.20 into 10 raised to, we have shifted to left, plus 2, so this is minus 7 meter, right? Then 14th one is 1.4 GM, which is nothing but 1.4 gigameter, and that is the diameter of sun. So you can write this 1.4 gigameter as 1 gigameter is equal to how many meters? 10 raised to plus 9 meters. So that equals to 1.4 into 10 raised to 9 meter. Right. And then 15th one is 40,000 kilo Dalton, Dalton, which is the average molecular mass of coronavirus. So I write this 40,000 into kilo, and this is Dalton. For this kilo, we can multiply this with 1000. Kilo means 1000, and then Dalton. Now Dalton is nothing but atomic mass unit. also called as just U, which is 1.66 into 10 raised to minus 27 kilogram. Then what I will do here, I will just transfer these calculations here. 40,000, 1,000 Dalton, and 1 Dalton is equal to 1 Dalton. Dalton is the name of scientist, John Dalton. To honor him, they have given name to this unit. 1.66, or just we can say 1.67 into 10 raised to minus 27 kilogram. So this we can write this as 4, 1, 2, 3, 4, 5, 6, 7. 1.67 into 10 raised to minus 27, and this happens to be 6.68 into 10 raised to minus 20 kilogram. Right, so this is the 15th example. We solve this example once again, and they will understand how to solve them. Some students might feel it difficult. I have told you, we have enough time. Don't be panicked. You should not think that this is just initial example and I am not getting. I am here to clear your doubt. So whenever we meet, definitely I will explain you still simpler way, because every student will have its own unique difficulty, and as I tried my best to make it simplified, but still some students might have not understood it. It's quite possible, and I have told you that once we meet, everything will be clear. Now I will give you 2 questions for homework. The first one is fill in the blanks. These are the questions from textbook exercise. Let's see how you complete this. Fill in the blanks. 2 are there. The first one is 1 kilometer is equal to, this is blank, and millimeter, how many millimeter, and one more, 1 kilometer is equals to how many picometer. Another one is 1 milligram is equal to how many kilogram, and how many nanogram. Same way we have to convert. 1 kilometer multiplied by 1 kilometer is equal to 1000 meter, and then all this you arrange and do it. I have explained some 15 examples. It is expected that you should solve this question. If you are not getting, I will explain it in the next class. See this one. This also from exercise only. Let's see how you solve this. If the speed of light is 3 into 10 raised to 8 meter per second, calculate distance covered by light. Distance covered by light in 2 nanoseconds. This is the second question. This is also homework for you. Sincerely you solve homework so that you will understand how much you have gone through this concept, because if you do not solve questions, you will not have any idea about how difficult or how simple they are. One more class 3 example I give you. Vanadium metal is added to steel to impart strength, to give strength. Vanadium is added. The density of vanadium is 5.96 gram per cubic centimeter. Express density, this density in SI unit. What is the SI unit? Kilogram per cubic meter is the SI unit. You have to convert that. Gram per cubic centimeter, gram cubic meter. Yes, solve this homework 1, 2, 3 homework, and previously 15 example, more than enough to understand the conversion of units. Yes, so thank you for watching this video patiently. Thank you.